The next problem, read this and decide what kind of a hypothesis test this is. In a study of 420,000 cell phone users, 172 of the subjects developed brain cancer. Test the claim that cell phone users develop brain cancer at a greater rate than that for non-cell phone users. I feel like this problem is a little outdated because how many people are not cell phone users? It feels like there's very few of them remaining, so it's not like we have a large pool of people to draw from. But I'm just going to go ahead and use this example anyway. We are comparing, our data is for people who use their cell phones. Is this about mu? Is this hypothesis that we're testing going to be about the population mean? So down here in question 16, we say no sample mean is provided in this question and there is no data. Is this a test of a population mean? No, it's a test about the population proportion. So it's going to be about P, and then we will be testing using P hat. So let's identify the letter or symbol for each of these numbers. 420,000 people were studied, that is our N. 172 of them developed brain cancer, that's our X. And then we're going to have P hat is equal to X over N. So we're going to have to take 172 and divide by 420,019. So let's see what that is. 172 divided by 420,019. Enter. Okay, here's our scientific notation again. So we get 4.095. So I guess I could say okay, so this is going to be E negative 4. I could just say 4.1 E negative 4. And then recall that this really means 0.00041. That is our P hat. Now that is a little higher. That is a little higher than the rate for non-cell phone users, which was 0.0340%, which is 0.00034. So this one's slightly higher, but they're in the same ballpark. And this is this is the population proportion for the null hypothesis. So the null hypothesis is that nothing happened, nothing is up. Our default hypothesis is that the population proportion is still the same and that nothing happened because we used cell phones. It hasn't changed things at all. If we get enough evidence, then we will find evidence to support this alternate hypothesis that for cell phone users, there's going to be a higher percentage of people with brain cancer. Okay, so we already found P hat. It's 0.00041. So that was the process for finding it up here. Since P hat is higher than 0.00034, does that automatically prove the alternate hypothesis? No. We have to go through the process of finding the area P to see if this is just slightly weird or if it's a statistically significant difference between these two numbers. You can never just use your gut and look at them and say. You go through this hypothesis testing process. So let's go to stat tests, and then we're going to choose the one prop z-test. P0 is 0.00034, x is 172, n is 420,019. Notice we don't have to put our p hat in because we are giving it the x and the n, so it will take care of that. And then this time we're saying p is greater than p0. And then I always like it to draw for me. Go ahead and draw. And there's my picture. But I can also see that z is 2.4434. And so that's fairly high weirdness. Remember, z-scores can go from -3 to +3. My area P is 0.0073. And then p hat, well, we still have our p hat from before, but I think if I had gone through stat tests, option 5, and then just said calculate, let me see, yeah, that gives me the p hat again as well. So it's 4.1 e -4, which is 0.00041, and n was 420,019. Okay, so I just copied all that information off of there, and now I'm interested in this drawing, which I had just displayed, and did this go off the page for you as well? To redraw this. Okay, so stat tests, option 5, everything's the same, make it draw again. Okay, so we're just way over here with our z-score, very small area P, and you would think, okay, that's gonna definitely be reject the null hypothesis. But our area P was 0.0073, and our alpha was 0.005. So which is going to be our conclusion? Remember, the lower the P, the higher the suspicion. I'm already pretty suspicious. This value is pretty far out in the fringes. But we had set a very small alpha of 0.005, and our area P is bigger than that. So unfortunately, we failed to reject, or maybe fortunately, because we set such a high threshold for this hypothesis test that we were unable to meet it. If we had set our alpha to be 0.05, which is a common value to pick, then we would have definitely rejected the null hypothesis. But we picked this tiny value of alpha, so we failed to reject H0. And so for this one, I'll just go ahead and hop down here. There is not enough evidence to suggest that cell phone users have higher rates of brain cancer than non-cell phone users.